Welcome to the fascinating world of chemistry. It's a journey into the fundamental building blocks of everything around us. When you think of chemistry, you might picture scientists in lab coats carefully observing bubbling beakers and colorful chemical reactions. But the truth is, chemistry isn't confined to the laboratory, it's literally everywhere you look. At its core, it's the science of matter, exploring what everything is made of, understanding how it behaves under different conditions, and unraveling the mysteries of how it changes and transforms. From the smallest grain of sand to the largest mountain, everything you see, touch, or taste is composed of chemicals, including the complex and amazing structure that makes up you. Chemistry provides the explanations for everyday phenomena, like why cakes rise so fluffy and light, how soap effectively cleans away dirt and grime, and even the frustrating reason why bikes rust over time. It might seem like magic at first glance, but it's not. It's simply a series of chemical reactions constantly happening all around you, shaping the world as we know it. Understanding chemistry is like having a decoder ring, giving you the ability to decipher the secrets of the universe. The power source in your phone's battery, the ingredients that make up your toothpaste, and even the nutrients in your breakfast. They all function and interact because of the principles of chemistry. Ultimately, chemistry is the story of how incredibly tiny particles come together to form absolutely everything we know and experience. By delving into the world of chemistry and learning its concepts, you're not just memorizing isolated facts. You're actually learning the fundamental language of matter itself. Throughout this series, we will break down the core basics so you can truly appreciate and see just how incredibly cool and relevant chemistry really is to your life. So, let's put on our thinking caps and get started on this exciting journey. Let's start with the very essence of everything around us, the basics, atoms. These tiny particles are the fundamental building blocks of all matter in the universe. Atoms are the smallest units of matter, retaining the chemical properties of an element. They're incredibly small, far beyond what we can see with the naked eye. Think of them like single Lego bricks, each one unique and essential. Elements are pure substances, meaning they are composed of only one type of atom, nothing else. They are the simplest forms of matter. For example, think of the element gold, with its shiny and valuable properties. Or consider oxygen, the very air we breathe, essential for life. The periodic table is a comprehensive catalog, a well-organized chart of all known elements in our universe, each with its own unique properties and characteristics. These elements, in turn, combine in countless ways through various chemical reactions to make up everything we see and touch in the universe. When atoms bond together, sharing or exchanging electrons, they form molecules, the next level of complexity. Molecules can be made of the same element, like O2, where two oxygen atoms join together, or they can be made of different elements, creating a vast array of possibilities. When different elements bond together in fixed ratios, meaning a specific number of each atom, they form compounds. A common example is water, H2O, where two hydrogen atoms bond with one oxygen atom. All compounds are molecules because they are formed by bonded atoms, but not all molecules are compounds, as some molecules consist of only one element. So, remember this key relationship: atoms make elements, elements make molecules through chemical bonding, and molecules, when formed from different elements in fixed ratios, make compounds. These simple building blocks, atoms, elements, and molecules, combine and arrange themselves to create the incredible diversity of matter all around us. That's the fundamental foundation of chemistry, the science of matter and its properties. Now that we've covered the basics, let's dive deeper into the fascinating world of chemical reactions and interactions. Atoms aren't solid balls, they're made of smaller parts. The nucleus at the center contains protons and neutrons. Protons have a positive charge and define the element. One proton is hydrogen, 6 is carbon. Neutrons are neutral and help hold the nucleus together. The number of neutrons can vary, creating isotopes. Electrons are tiny negatively charged particles orbiting the nucleus. The attraction between protons and electrons holds the atom together. In a neutral atom, protons and electrons are equal in number. Electrons are the key players in chemical reactions. Understanding these particles helps explain how atoms interact. Next, let's see how atoms form compounds. The magic of chemistry happens, creating the world around us, one bond at a time. When atoms, the fundamental building blocks of matter, bond together to form compounds. These compounds dictate the properties of everything we interact with. It's all about the outermost electrons, also known as valence electrons, that determine how atoms interact. These tiny particles hold the key to understanding chemical reactions. Atoms are driven by a fundamental desire to achieve full outer shells, a state of stability and lower energy. To achieve this, they gain, lose, or share electrons with other atoms to get there, achieving that coveted full outer shell. Let's consider a common example: table salt. Sodium, a highly reactive metal, readily gives up an electron, while chlorine, a poisonous gas, eagerly takes it, forming charged ions, one positive and one negative. These oppositely charged ions attract each other strongly, resulting in an ionic bond. Another fundamental way atoms bond is by sharing electrons, a process called covalent bonding. Take water, for example. In each water molecule, oxygen shares electrons with two hydrogen atoms, creating strong covalent bonds that hold the molecule together. These bonds hold molecules together, defining their shape and structure. And it's these bonds that ultimately dictate the properties of the resulting compounds. Whether by giving, taking, or sharing electrons, atoms form the endless variety of molecules and compounds, creating the vast array of substances we see and use every day. That's how chemistry, through the simple act of atoms bonding, builds our world. Now, with a grasp of how compounds are formed, let's delve deeper and see what happens when these compounds undergo change. Chemical reactions transform substances into something new. Atoms aren't created or destroyed, they're rearranged. Bonds break, new bonds form, and new products appear. Baking a cake, heat triggers reactions, baking soda releases gas, batter rises, flavors form. Cleaning a greasy pan, soap molecules grab oil and water, letting you wash grease away. Chemical reactions power life. Photosynthesis turns sunlight into food, combustion releases energy. Understanding reactions explains everything from fizzy drinks to burning stars. Chemistry reveals the rules behind how matter changes. It's not just for tests, it's for understanding the world. By learning chemistry, you unlock the secrets of how everything works, and that's the real magic.